Hello, good evening. Welcome. I see a lot of people way back there. We don't bite. Why don't you just come up front? There's a lot of love here. So welcome to the Bay Area Apache Spark meetup here at Salesforce. We're delighted to be back here in the Peninsula. We normally try to alternate between the Peninsula and San Francisco. Our next meetup for this particular thing was going to be at the Spark Summit on the eve of the Spark Summit, which is on June the 5th. So how many of you have been to the Spark Summit? Great. If you want a t-shirt, you might want to raise your hand. All right. So our next meetup is going to be over there. So do sign up to come. My name is Jules Damji. I'm the Spark Community Evangelist. And I do really want to thank Salesforce for sponsoring us. This is our second meetup. They've done it. They've done an incredible job, Holly and Amanda coordinating, and also Alexei, who has been an advocate of Apache Spark and Databricks. And I'm what I'm going to do is have him come and introduce our two speakers who are going to talk about machine learning and Apache Spark and how they're actually using Spark in Einstein and in other ways they're actually using the product at scale. And Alexei is the director of machine learning, so he's going to give a little brief introduction of what they are, and they're going to introduce the speaker. So give him a big welcome to Salesforce, Alexei.
Thanks, Jules. Very happy to have you again here. So we will have two talks today on Spark, but before I do that, essentially a lot of work is happening here in Palo Alto around data engineering, data science. So you guys probably heard about Einstein, and a lot of the applications are being developed here. So we have a few offices. This is our main hub. We have actually have three small offices around here, and this is where we all get together. We'll have two different talks today. One will be on Spark and like a dependency injection, and Shu and Sandeep will present on that. And then we'll have Sami will be talking about essentially some of the machine learning work we're doing for one of productivity application called Inbox. We'll do Q&A at the end of the presentations, and then we'll stick around probably if you're interested. And then there'll be also one talk from Databricks on streaming. From a logistics standpoint, we don't have it displayed anymore, but the Wi-Fi is SFIQ guest, and it's hash customer love hash with chemicals. If you need to use restroom, they're all the way at the back. You have to follow the left side. That's it on our side. If you're interested and if you want to explore opportunities, we have a lot, right, around backend engineering, data engineering, machine learning. So come talk to us. We have a few Salesforce folks here. Thank you, and without ado, I will introduce Sandeep and Shu.
Hello. Hey everyone. So today we're going to be talking about dependency injection. Just a couple of words before we start. This is the engineering part of the Spark. Spark has engineering and the data science. So this is not a data science talk, engineering talk. And then this has a set of prerequisites. You need to know what dependency injection is, which I assume a lot of people here do. So let's get started. So for the next 20 minutes, we'll be talking about what Signals is, the team which we work on, and then how do we use Spark in our team, and then we'll dive into the meat of the talk, which talks about how to do dependency injection in Spark applications, and then we'll walk through some examples and see some running code, and eventually we'll wind up talking about the pitfalls, trade-offs of dependency injection. So that's what we're going to be doing in the next 20-25 minutes. So to start with Signals, Signals is a platform where we have activity streams. We have a lot of data coming from emails, calendar data, and SMS and things like that. So we have this platform lets us kind of get insights out of this data by by data processing. And how this helps us is it helps salespeople a lot since they get a lot of emails. This platform helps them prioritize the emails and lets them concentrate on the emails which matter the most. And that's what Signals does. But under the hood, on an engineering aspect, what Signals is built on is a couple of Spark jobs and this is like a typical data pipeline where you have data in your Kafka or S3 or something like that, and then you have Spark jobs doing some sort of enrichments or some sort of transformations or even like aggregations over time windows, and we write them back to Kafka. So all our jobs use structure streaming, and we deploy all our jobs on Apache Mesos. So, yep, so diving right in. Let's actually see like a very simple Spark application. So this is, just let me know if the font is like a little small. Is everyone able to see this? No? No? Okay. Let me see if I can zoom this. How about now? Is this better? Okay. So what we have here is like a very simple Spark application. It's like a simple word count application. Reads from a TCP socket, does the transformation to like, get word counts and writes to Redis. So that's what we have right now. So let's see what happens here. This is like a very typical way you write Spark application. You get the Spark session, and then like, you get the lines from your TCP socket. This is like a function which has like a TCP reader. And then you do the transformation, and then you write it into Redis, right? So we are using like a custom for each writer, where if you go here, you can see that there is a writer which extends for each writer, and we have like, open, which creates this Redis connection and then writes it. And so, yeah, like pretty typical Spark application. So let's try to run this and see how it works. So what I have here is like, I think I probably have to zoom in again. So what I have here is like a Redis monitor, which let me see what commands I'm sending to Redis. And here I have like a TCP server running on 9999, and then let's see how this works. So let me run this, and then so we'll be running like the basic example. Yep, it's running, and then I can do something like this, and like, the Spark job's running, and then I can see like, hello, like something like this. Again, it updates the count. So like pretty typical Spark application, right? So if you see what's happening here, a lot of this is very basic, right? You can't put something like this in production if you want to run this 24/7, 365. So what we need is a set of functionalities to make it more maintainable, to make it more composable. So what we need in our Spark jobs are, we want our Spark jobs to be testable, and the way we want to structure our Spark jobs are, we want to like define something called as components, where like, you have like this basic functionality which is called a component, and then you like, mix and match those components to build bigger components or dependencies. And then you want to be able to like, define dependencies and reuse dependencies, right? And at the same time, the reason why you're doing this, all of this, is because you want your Spark jobs to be loosely coupled. Like, the dependencies have to be loosely coupled, and at the end of the day, you should be able to like, run this in different environments. Let's say you want to run like test cases. Let's say you want to run this in staging or production, or you might want to like swap out like, your implementations. Like one classic example might be like, let's say you're using Redis, and then like, test case, you're like testing like a different functionality where you don't want Redis. You might want to like swap that out with like, like a concurrent hash map, or even like a mock version of like a Redis or something like that. So should be able to easily do that, right? So that's the goal which we're trying to aim at. So one of the ways which we can do this is by using like a dependency injection framework. And what we use in this as a demonstration is something called as Guice. So before we start with Guice, I just want to set the stage, like, just to make sure we all know what dependency injection is. Like couple of lines, dependency injection is like a design pattern, pretty popular. Lets us create like, very loosely coupled composable dependencies. And it has two things, something called as a dependency and something called like a functionality which you can inject dependencies onto. So like two components. So it's very, like it lets you write very testable, loosely coupled code. So this is like, like a quick intro on dependency injection. So let's see what Guice is. Guice is like a dependency injection framework written by Google. It's open source. It's pretty popular, easy to use, highly configurable. It's written in Java, And the best thing about this is it is framework agnostic. It's like very minimal. It doesn't let you tag on to any other framework. It's independent on its own. You can use it to do dependency injection on anything like web applications or like any sort of random Java or Scala or JVM applications, I would say. It also implements, it conforms to the Java standard. It implements JSR 330. So yeah. So let's see how we can transform our simple Spark application to use Juice. So let's take a look at this quick example and see how that transforms our example. So we have the same function here. Yeah, probably I should zoom in. So the same function, we're reading the Spark session. I mean, we're creating a Spark session, creating a stream. Then instead of having this word count, we have abstracted that into like a different class. So what we do is we create something called as an injector, which would take something called as a module. And then using the injector, we create an instance of our example, and we get like an instance of that. And on the instance, we call word count, like count word, so that this is kind of like more modular. If you see what's happening here, we have something called as like a juice example. Inside this, we have count words. But the most important thing here is that the writer, which is injected. So the core logic is that the count words does not even need to know how the writer is implemented. So the implementation of the writer is totally independent of the logic which you want to use, right? So like it's more of like it's separation of concerns. You shouldn't like the code the core functionality shouldn't bother about how dependencies are being created. So the writer is being injected here, and if you see the writer, it injects the Redis client. So even the writer doesn't know how the Redis client is created. It's again injected. So the Redis client can be created in any way, and then what it does is it just gets injected here and it sends it. So to contrast this, if you go back to this previous example, and if you see this, the specific thing where the Redis writer was explicitly creating this Redis client, but in the new example, we don't have that problem. What we have is like an injection going on, and then this Redis client is getting injected onto the writer. And how is this all wired up is using something called as a module. So module has like providers, like provide Redis client and provide for each writer, and then you can create your objects here. So this makes sure that your code is reusable, where if you want like your Redis client to be used in multiple places, you just define it once and you inject it so that like regardless of whichever part of the code you have this injection, you get that object automatically there. So this looks nice. It looks pretty modular, and it seems to like make your life a lot easier. So let's run this and see what happens. Okay, so let's run the juice example. So it starts, and then it fails, right? Like it clearly fails. It seems to like it starts up, but when you send the data, it fails. So let's see what's happening. If you look at the logs, you'll see something like this. This is like a very typical error, right? Like when using Spark, like Spark's not serializable. So what's happening here is it says like the object is not serializable, and what object is it? It is like this Redis client. So what's happening here is pretty simple. So Spark isn't like like it can run on one machine, it can run on 10 machines, it can run on 100 machines, right? So it's like a distributed platform. But what's happening here is Juice, which is like a dependency injection framework, doesn't know that. Dependency injection framework like can be used in any applications, right? You like in this case it's being used in distributed computing platform, and it doesn't know that it's being run in multiple machines. And what happens is Spark internally ships all of these tasks to the executors. So like this is where the driver program it starts, and then it essentially sends all of this code to the worker nodes. So what's happening here is these tasks, which are to be sent to the driver, to the executors, has to be serialized so that like it can be shipped over the network, right? But the problem is not all dependencies are serializable. Like in our case, like the Redis example, right? As soon as you start the program, the program creates all these dependencies and like gets it ready so that you can start using it. But the problem is the network connection, the connection to the Redis happens from the driver, not from the executor. That's not where your code runs. So that's a problem, right? And then Spark doesn't know this, and it tries to serialize this, and it gets an exception. And the other thing is not only network connections, a lot of libraries, which is pretty common, right? Like we use a lot of third-party libraries and something on Maven repository or something. So not all libraries are in our control. We can't expect all of these libraries to be serializable, right? So this is like a pretty common problem if we try to use dependency injection on Spark. So yeah, Shu is going to talk about how to solve this and how to get Juice working on Spark.
Hey everyone. So yeah, as Sandeep mentioned, basically the issue that we ran into is the fact that not all dependencies are created equal, right? Some of them are serializable, some of them might not be. And the question is, how do we get these non-serializable dependencies to be serialized? So what if, instead of actually serializing the instance of the dependencies, which is what we saw in this juice example, right? All the different instances get created on the driver, and then those instances try to get serialized. Instead of that, what if we serialize the configuration for a dependency? Basically, the way that the dependencies get created. And then we can actually construct those instances of the dependencies on the executors. So basically, what we're saying is we want to create a juice injector, which is in and of itself serializable, and it also knows how to inject all of the dependencies lazily. So this is where Injector Provider comes in. It's an internal library that we've written at Salesforce IQ, but we're planning on open sourcing it very soon. It's basically a wrapper on top of Juice that creates a serializable injector, and it also makes sure that the injector can lazily load all of the Juice modules. And thus, it can also, as a result of that, lazily load all of your dependencies. This way, your executors are not actually shipping instances of the dependencies. All they have to do is basically send the serialized injector with the task, and when the task gets deserialized, the first thing that'll happen is your injector will be deserialized, then your injector will inject all of your dependencies. And this will happen on the executors, and ideally, if we can do this, then everyone will be happy. So let's take a look at the code for using Injector Provider then. So if you look at this example, just like the Juice example, it's actually very similar. This is the main method where, again, Spark session stream. The thing that we've changed here, instead of using Juice to create the injector, we're using our Injector Provider library. And we are still providing our own specific Juice module, which is just a different one now, right? And just like the Juice example, we're getting the instance of our class and calling count words. So let's take a look at the class that we're getting an instance of, right? It's defined right up here. And just as with the Juice example, we're doing the same kind of thing, injecting in the constructor our for each writer. And the count words is actually the exact same as the Juice example. The one caveat is that we're extending this abstract class that we've also given in the Injector Provider library. And this abstract class basically does some of the niceties of deserializing your injector and injecting all of your member variables whenever this object gets deserialized. So let's say you cannot use this abstract class because, for example, our for each writer, it already extends from one different class. So we know in the JVM you can't have multiple, like one class inheriting from multiple classes. So in this case, we allow you to solve this issue as well. What you have to inject is this injector stub. This object basically has the injector inside of it. And this guy, one important thing to note, this guy right here is actually serializable. And we still pass in the Redis client, right? And what we do here is the private variable that is the Redis client of this writer, it's annotated transient. right? This ensures that the JVM does not try to serialize this object when it tries to send it over the wire. So this is the issue that we were facing before, right? If this were not transient, then Spark will try to serialize it, and it would fail. So by making it transient, we're making sure this doesn't get serialized. What we do instead is basically in this read object, this method is part of the Java serializable interface. What we do is we do the default reading of the object. This guy will basically make sure your stub gets created when it gets deserialized. Now that we have a valid stub, we can call the inject members, and this will basically look at all of your member variables and methods that have the inject annotation and provide the proper dependencies at that point. The rest of the Redis client is exactly the same, by the way, just setting the words. And if we look at the Juice module, it's pretty much exactly the same. We're providing the Redis client and the for each writer. So let's take a look at what happens if we actually run this code. So now we're going to be running example 3, which is the Injector provider version. So it's running, and our Redis CLI, let's clear that out if we can. I guess we can't, so here we go. So if I write hello world now, ideally, our example should run properly. So it looks like we're not getting any serialization issues, and we do have indeed new counts for hello and world. And if we do it again, we should see 2 for each. Yep, so looks like it's working properly. So what are some of the good things that we get out of this? So if we go back to this example, right? One of the important notes is the fact that the class that we have here, defined right here, it's getting injected a for each writer, and it doesn't know the implementation. So in production, we could be using Redis, but let's take a look at a test case instead. So here's a test case. Again, getting a Spark session and creating our, basically our stream from a file that we've written. It just has the words hello and world a bunch of times. And we get this injector, same kind of thing, create the injector. And this time we actually provide a different module. This one's meant for tests only. And again, we get the instance of our class and count words on it. And we just, at the end, assert that the values are correct. So let's take a look at what this module is actually doing. This module, when it provides the for each writer implementation, it's actually providing an in-memory version. So the definition of this is this class right here. What it does is it actually just populates the values into this word map, which is just a concurrent hash map. This basically allows us to not have to spin up Redis just to run our unit tests, which is definitely makes it a lot easier to write testable code. So ideally, if we were to run this test case, then everything should still be nice and dandy. So it's doing something, right? Writing words, and all tests passed. So basically, we were able to swap out our implementation of the writer to do something that's in memory, and our test cases still worked. So what are some of the trade-offs of using this injector provider? Well, one, it's not very straightforward, but it's definitely necessary, right? You have to do this whole deserialization step, and when you deserialize, you have to inject all of your member variables. Definitely not as straightforward, but like we saw, if we wanted to use dependency injection, this is something that was necessary for us. And it also ties you to Juice as your dependency injection framework. So some overall conclusions. We basically saw that creating modular Spark jobs is definitely not that easy, and dependency injection in Spark isn't that straightforward. And this is mainly because Spark tasks have to be serializable, so any kind of dependencies you have any instances of those dependencies must be serialized. We saw that plain old juice just doesn't work on Spark because of the issues that we just saw above. And what we really need to make it work is to create an injector, a juice injector, that one is serializable, and two can load your juice modules and all of your dependencies lazily. And that's what makes DI possible in Spark. And in order to accomplish that, we've basically created this injector provider library, which is soon to be open sourced, and it gives you the ability to do just that. And I'd say that's pretty juicy. If you guys have any questions, feel free to ask.
A couple of questions, feel free. We have a couple of mics, one of the little box that we can throw around. I'll give you my mic.
Yeah, I just wonder, like, basically you wrote a dependency DI framework for Spark, and that is kind of take care of the serialization and deserialization problem. Did you guys explore Spring framework, or was there anything already available that you guys explored and didn't find it good enough that you had to write your own?
So one of the main reasons that we had to write our own is actually because internally within the other libraries that we've written at Salesforce IQ, we rely heavily on Juice itself. So because of that, we actually had to we were specifically tied to Juice as our dependency injection framework. And in order to make Juice work, we had to go with this route.
Will this work with Java as well?
Yes, so the injector provider library is actually written completely in Java, and it works with it as well.
Gentleman with the question? Yeah, go ahead. Doesn't work?
Does this work for more complex structures and the libraries you don't have access to?
Yes, so as you saw in the example, if we actually look back at the example, so in this module, this Redis client wrong place, hold up. So this Redis client right here is actually not something that we've written. It's a third-party library. And we basically used this injector provider to make it work for us, right?
Who's doing the serialization?
Oh, so I guess the way that this is working underneath the hood is not the fact that we're not serializing this Redis client, actually. What we are serializing is this Juice module, as well as the injector. And what happens is when you need an instance of the Redis client, like we do in this writer, the first line in this read object that you see, right? This deserializes your injector, which is a serializable object. That injector also inside of it basically has access to your Juice modules, and so when it calls this inject members, that's when it creates the Redis client. So it's not actually creating the instance. Yes, we're serializing the wrapper completely. So your object gets instantiated on the executor.
Oh, we'll take one more.
Have you looked at things like Dagger, which provide compile time DI rather than reflection based? Does that make a difference at all?
Go for it.
No, I mean, not really. I mean, we haven't tried Dagger, so that's probably something we should look at.
Guys, give a big hand to Sandeep and Shiv. They're going to be around, so if you have any more in-depth questions, you can take it offline.